Dear Maryanne, as I read your second letter, Under the Big Top, An Unusual View of the Reading Brain, I particularly appreciate how you begin with Emily Dickinson's poem. I think her first line, "The brain is wider than the sky," sets the tone for this letter. The brain is truly a marvel. In the undergraduate and graduate literacy courses I've taught over the years, I've routinely spent some time explaining how the brain learns to read. But if I'm honest with myself, my explanations have been overly simplistic. Perhaps I didn't really give my students enough credit for understanding the reading brain, and this is a strong possibility, I didn't feel I had a firm enough grasp on the role of the parts of the brain to be able to adequately explain how the various parts work conjointly to facilitate learning to read. So thank you for honoring your readers enough to take the very weighty subject, the subject of your research, and create a narrative that enables all of us to understand the reading brain. Your second letter is so very important, and I hope I am able to convey the important points to my students. I realize that in my letter to you, it will seem that I'm providing information that they can just as easily get by reading your book. But I'm remembering the first time I read Reader Come Home, and I knew that I would need to read several passages more than once to fully appreciate your descriptions, even aided by the wonderful illustrations. So I hope to, through this podcast, through my letter to you, enhance my students' understanding. My graduate students, after all, are employed teachers with very busy lives, and I don't want to assume that they'll read your book 2 or 3 times, as I have done. And I think the content is so important. Anything I can do to help them to really own the content about the reading brain may be useful. I think it's important, as you make a point of explaining, that the human brain is not hardwired for reading the printed word. Reading is a unique invention of humans that we were able to acquire because of the powerful processes associated with brain plasticity, the brain's ability to rewire itself over time to complete new functions. If we think of the brain as a computer, plasticity is like when we add new software or install new hardware. But computers cannot compete with the brain because the plasticity of the brain is designed to accommodate the changes over time. The description you provide of the reading brain using the big top or circuit du soleil, I love that, makes it so much easier to visualize the functions of the different parts of the brain and how they interact when we read. I really appreciate Catherine Studley's artwork as she, in Figure 1, provides us with a bird's eye view of the left hemisphere and the regions that facilitate reading. In fact, I found it very helpful when reading pages 20 through 24 to use my phone to take a picture of the figure so that I could download it to my computer and easily go back and forth while reading the description of each ring in the circus. This worked well for me so that I wasn't constantly going back and forth on the pages. The important thing is the overlapping regions of the brain, and the illustration makes this clear. In thinking about teaching in general, and thinking about how children learn, it makes sense to point out the smaller rings of motor function and affect first. It is in the motor ring of the circus where performers carry out the functions of articulation as they interact with the performers in the larger language and cognition rings. And the performers in the affect ring work with the other performers to connect our feelings to our thoughts and words. Teachers are well aware of affect when it comes to learning and how important a student's feelings about what they are asked to learn and do are to motivation. You've also made the discussion of the prefrontal cortex fun by describing it as the place where all manner of very important persons seem to be executing their very important things. This is where the executives work and complete executive functions. I think teachers often hear about the need for executive functioning in order for children to learn. Those things like being able to pay attention, focus, and self regulate behavior. Indeed, the work of those very important persons, those executives in the prefrontal cortex, is very important indeed. The larger rings in the Circuit du Soleil are more obvious as we look down from the top of the circus tent. The performance we see in the vision ring encompasses much of the occipital lobe and cooperates with performers in the midbrain and the cerebellum in order to create automaticity in all activities. And we know how important automaticity is when reading and learning to read fluently. Suffice it to say that the locations and overlaps of the various rings illustrate the complex interplay that occurs when children learn to read and engage with the English writing system, a system that is logographic, using symbols like letters to represent language. But as you describe, a circus needs spotlights. I remember as a child going to the circus and that moment when the spotlights flicked on and began flooding the big top, circling around and around until the performers were in place, sometimes on the high wire at a dizzying height. All the floodlights would converge on the high wire performers, drawing our rapt attention toward them. The reading brain needs spotlights too. These are what you call biological spotlights that are essential in drawing our attention to the word or words we read. You describe the three functions of the biological spotlights in a very rapid process. They first draw our attention by disengaging us from whatever we were originally paying attention to. Second, they move our attention to what is in front of us. For example, the word in front of us that needs to be read. And third, the spotlights focus our attention and signal to the reading circuit to get ready and prepare to perform. A number of areas in the brain are attuned to the spotlights and are ready to spring into action. The performers on the high wire are ready to go, but other performers are on the ready too, as are the executives, creating the cognitive environment for everything to work according to plan in the Circuit du Soleil. Now is, as you say, something astonishing happens. The action we've been waiting for begins. Let's say the spotlights at the circus have directed our attention to the high wire performers in the vision ring, and we see that there are actually two different wires. Again, thank you, Catherine Studley, for the illustration on page 27 that helps us visualize all the performers and their roles within the Circuit du Soleil. On each of the high wires overhead, we see two sets of cyclists, all set and ready to take off across the wires. And off they go at the same time and at lightning speed. It's quite a show. What we are seeing in this big top is that the performers are traveling along paths from both eyes simultaneously, with some cyclists traveling to the left and some to the right along their ways to the occipital region of the brain. Along the way, the cyclists pick up messages as sets of letters that will be delivered to their final destination. As you describe, the ring of vision in the occipital lobe becomes whirl with activity as the messages from high wire cyclists are transferred to clusters of tiny orb like creatures that look like little eyes with arms and feet. These little orbs have different tasks. Some identify messages as letters and scurry to pass that information on to other orbs that are responsible for ensuring that the letters are indeed real letters. Another group of orbs picks up this bit of information and verifies that they are actual letters that are well known English letters. In the example, you give the letters T, R, A, C, K, S. Other orbs spring into action, each knowing their specific tasks. Some, for example, focus on individual letters and sounds. Others respond rapidly with letter patterns found in words like ter and ak. Others, too, specialize in recognizing morphemes, those parts in words that carry meaning, like the S at the end of track that makes it plural. And other orbs grasp on to the letter combinations that create whole words already known, sight words like cat, dog, the, and stop. And all of this whirl of activity is possible because of the remarkable design principles referred to as retinopic organization and representation, which facilitates the precision of activities required of all the performers, the cyclists and orbs, to deliver and make sense of the letters and words. Performers in the language ring now spring into motion. This is a dizzying performance, with acrobats flying through the air, others spinning plates on long sticks, and some delighting us with magic tricks. In the language ring, all those letters and words are in search of a place to land, to find meaning in language. If we go back to the letters that came together to make the word tracks, our brain begins rapidly trying out possibilities for the meaning of the word, drawing on probabilities and predictions, as well as context and prior knowledge. And with assistance from the prefrontal areas, the brain has a voila moment when the word tracks is identified as carrying meaning in our language. And as you say, Maryanne, this is when the fireworks commence. Tracks. All the performers in the language ring begin offering suggestions about the meaning of tracks to be applied. I mean, could it be animal tracks, sports tracks, train tracks, or maybe audio tracks, one track mind type of tracks? And it can go on and on. Goodness, there are so many ways to think about the word tracks. But help comes in the form of trapeze artists who swing in and draw our attention to the cognition ring. And as they sway back and forth, they whisper questions about the context of the word tracks. They are prompting the reader to make meaning of the word, and as figure 3 on page 32 makes clear, the word tracks in this instance obviously refers to train tracks. All of this brain activity happened so quickly, a little more than 400 milliseconds, so we sometimes take it for granted. But it is so important for teachers to understand the distinct roles of the various parts of the brain that enable reading to occur. Finally, Maryanne, thank you so very much for ending your letter with a discussion of empathy. Even these very, very rapid actions in the reading brain serve as a foundation for understanding the nature of empathy. You provide examples from how young readers react to mental images associated with the little train that could and Thomas the Tank Engine, and how they often evoke a pleasant emotional reaction. But you also remind us what it is like to read the passage in which Anna Karenina is about to throw herself across a set of train tracks in despair, and how it evokes a sense of dread and sadness and empathy for Anna. It reminds me that reading is not merely an act of decoding or even comprehending words. Reading is a human act that teaches us so much more. It teaches us about life and about humanity. This is where reading and living come together. I look forward to your next letter about deep reading. So until then, I'll close with yours truly and with love from your readers.